Hello there. In this video I will be covering some of the primary concepts when dealing with variables. This video works off the premise that you will have watched the previous video where I covered the fundamental basics of setting up your C project. There should currently be a card on the top right of the screen to that video. Presuming you have followed that video, you should have a basic project structure which looks somewhat like this. In your case, your out folder might be empty. To get started, I will be opening my main.c file in the editor of my choice. You can use whichever editor you wish and have installed. I will be using Vim. In C, if we wish to declare variables, we have to specify which type of variable they are. This means that if our variable is supposed to hold a number, then we must specify this when declaring the variable. To demonstrate an example of this, I will up here at the start of the main function, I will be declaring a variable to define a amount of money our player might have. As I do not intend for our player to be able to have cents, but only whole numbers for how much money they have, I will be using the integer type for this variable. Then we can just declare the name, so in my case money, and we can optionally also initialize it to a value such as 0. If you wish your player to have a certain amount of starting money, of course you could initialize the money variable to something other than 0. If you intended for your player to be able to have a amount of money with decimal places, then you should change this number to a floating point. Keep in mind, however, that floating point values have issues such as floating point precision, which are slightly too advanced for me to get into in this video. The gist of it is that at a certain precision level with floating point, the value they are assigned becomes less and less trustworthy. If we want to use this money variable in any form, we can, for instance, just as a very quick example, in our print statement here, can replace everything until the new line, and instead place a % sign, and then depending on whether our money variable is a float or an integer, either use an F or an I after the %. In the case of it being a float, I will be using the F, however otherwise you would be using the I. Then, after the quotation marks, I'm going to separate with a comma, and then specify money. What this does is that the print function understands when we specify %f to look for this money variable. If we use multiple like this, however, that will change. Of course, we can already then quickly test this out to see it working. I will quit out of my editor and resume into a terminal. Then we can make our project again and run the project. And in this case, because the value of money was initialized to 0, it just printed out as 0 point and then a couple of zeros. The couple of zeros is only because of the float in this case. However, if you would have used an integer for money, it would just print out a 0. We can resume back to our editor and continue. There are a couple of more things in terms of variable types. Firstly, there is the char. I will declare another variable, char, and then direction. Char stands for character, which means that this variable can hold a singular letter, such as, for instance, a U. I like to put singular characters in single quotation marks instead of double quotation marks, as this helps me denotate whether they are a singular character or multiple. As technically, when in C we want to define a string or a piece of text instead of just a singular letter, the way we would do this is we would have to declare a list of characters. The way this can be done is we can say char, and let's say we want a variable for a name, then we can just type in name, then we can put square brackets equals to, and then I will be using double quotation marks, and then we can just put in our name. Of course, I will also put a semicolon at the end of the line. Now, as it currently stands, without putting any value into these square brackets, what this will do is the compiler will count the amount of characters we have put here, so in this case 4, and automatically allocate the variable to only be able to hold 4 characters. This is clear if we were over here to try reallocate name to a really long name. Then if we were to exit out of the editor and try to compile it again, then generally C really does not like one trying to reassign to a string. There are basically two ways one can reassign to a string. One way which only works if it already has enough characters assigned to it, where the process would be that one goes through each individual character of a list of characters, which is how a string is functioning in C, and then just manually reassign each character to the new character to change the string. And the other way is, however this would require more knowledge on memory management, is to free up the variable and recreate it. Nevertheless, this should serve as a good introduction to lists. Lists can be used for a couple of different things, because as this is clear, the way we assign a string is just by saying that this is a list of characters. However, we can also have a list of floats or a list of integers. Or, for our next data type, there is a boolean. To use a boolean, you will need to include std_bool.h, with which we can then also define a variable to be a bool or a boolean. However, the keyword is bool. We can use this to say, have a variable which defines whether our player is on the floor. We can initialize this to true or false, and we can, in an if statement, simply check if on floor. As you may have realized, it is of course also possible to always define a list of any of these data types by just putting these square brackets after it. However, technically in some cases you should be putting a snowflake before the name of the variable. This defines them as a pointer. Without getting too deep into memory management, a pointer is a form of list. We use square brackets if we know precisely the length of our list, so how many items we should have in the list, and put this number into the square bracket, such as in our case with the name, we might put in a 4 because the name just contains 4 characters. The last thing that remains to be covered is the struct. A struct can be defined by using the struct keyword, then the name of our struct, so say a player, and then we use curly braces. Here we're also supposed to put a semicolon at the end of the curly braces. Then inside of here, we can define fields for the struct. So we could have an integer for health, we might have an integer for money, we might have a string for their name, we could have a position, which one could also define as a struct. So we can have a struct of position. Of course, we also need the semicolon here, and the position is just 3 integers for x, y, and z. Now, the way we can reference a struct as a type of variable is we have to use struct pause, and then we put the name of our variable. So now this player struct has 4 fields, one for health, one for the money, one for the name, and one for the position. And this field is another struct which has 3 fields, one for x, one for y, and one for z. Now we can of course initialize a player just by saying struct player, and then the name for our player, player1. Now we can say player 1 dot health is say 100. We can similarly assign the money, so player 1.money equals 20, and the name player 1.name equals 2, and we put our name in the quotation marks. Now unfortunately, to define the position we have to go player 1.position.x equals to our value, and do the same for y and z. Now in some cases you may be initializing your struct as a pointer, so if your player has a snowflake in front of the player 1, then your compiler will be telling you that the dot is invalid, and instead you need to use a minus greater sign. Now there are 2 things which remain. The first is if we want the variable for our player to be also usable in other files. The way we can do this is by declaring him outside of the main, is the way I like to do it, and then we also need a main.h in our case. This is however, if you were to define your player within say utils.c, you would be doing this next part in utils.h. However, I will be doing it in main.h. In here we will need to copy over the structs, or well, move them over, and we can actually copy over the player here at the end, and we define him as external. We only do this part inside of the main.h and not inside of the main.c. However, for us to be able to define the player struct in the main.c, we will also need to here include the main.h. Then, if we want to use any information about the player, we can go into, say, utils.c, include the main.h file, and then say instead of our print hello function printing hello world, we can replace this with %s, and then here in our comma to define what %s is, we can say player1.name. Now, if we quit out of the editor and resume back to a terminal, then we can run make /us/program, and the function updates to printing the name of the player instead. And with that, I would like to thank you for watching. If this video was helpful to you, it would be greatly appreciated if you could like the video and leave a comment. Currently on the left side of the screen should be a playlist to all of my C tutorials, whilst on the right side of the screen is a video on the general basics of programming. No matter which language you are learning, that video will help you. Thank you.